Hi, Angela Horneman. I'm from the CERT division of the Software Engineering Institute at Carnegie Mellon University. I work on the situational awareness team, and I'm a general analyst, security researcher. What I find myself doing a lot is helping people think about the problems that they bring to me. Recently, I've had a lot of conversation and thought about the anomaly and indicator ideas, where we have customers come to us and they ask us, tell me about the state of anomaly detection, or help me implement anomaly detection versus signature detection. So I've been thinking about this, and I think this really comes down to a problem where a lot of the people who are putting in requests don't necessarily have a good understanding of what an anomaly is versus what a signature is. I'm going to talk about that a little bit today, but more importantly, what I want to do is I want to talk about ways that we can define events. As an analyst, we often get descriptions of events that don't really help us do our job. So I want to present a way that I have come to start to think about events in ways that I can define them and help me find them when I'm asked. So a little bit ago, I gave a little bit of a talk about security events. I'm very big on definitions. What I talked about was security events are a series of actions. In other words, one event does not just have one verb. Across some number of assets, you have a security landscape that's made up of many devices, many components, made up of people, made up your reputation. Those all go into your security landscape that adversely impact at least one asset. That's what makes it a security event. Events are not just actions or happenings. You breathe, that's not an event. What makes it an event is it is something of importance, and what makes it a security event is one of the actions causes harm in some manner. This is very much an organizational viewpoint definition, not the same happening may or may not be an event depending on the organization. For instance, not all organizations view scanning as a security event. Some, it's just something that happens. Others, it's a really big deal. When we think about events, most organizations have a pretty good handle on how to respond to known events, but they're a little bit hard-pressed when it comes to hunting for events that they don't have an alert to. So earlier today, we saw in our presentation a quote where either there are two types of organizations, ones that have been hacked and ones that don't know they've been hacked. Where you don't know you've been hacked, that's where hunt comes in. Hunt is really hard for analysts, especially because we don't often know, or we aren't told what we should be looking for. We're told that we should be looking for something of interest. As an analyst, what does that mean? I think about this as a four-step process where when we want to hunt, first we have to identify what it is that we want to find. Identify the events that we care about. So do we care about phishing? Is that what we're going to hunt for? Maybe. Usually more that's an incident response than an actual hunting activity. Do we care about exfiltration? SSH brute force attempts? What for our organization are the events that we care about that we need to go hunting for? Once we know that, we can start identifying the actions that make up those events. Those actions are what help us as analysts find those events in our network logs, our other sensing architecture. But even if we know the actions, a lot of those actions can make up legitimate legitimate communications or happenings as well, which would not be an event. So for instance, when you have SSH attacks, that generates a lot of network traffic. If you can see the network traffic, well, there's a lot of legitimate network traffic too, even to your SSH server. What is it about that what are the actions of an attack would indicate that something is illegitimate versus legitimate? Once you've identified that, you can prioritize those by the ones that are least likely to be legitimate and start looking for those actions first, assuming you actually have the sensing architecture in place that you can find the actions. What I really want to get at here is, for an analyst, we need to define events based on actions. So we don't say that an SSH brute force attack is somebody just tried a large number of passwords using the same user ID to attempt access to our SSH server. What we need as analysts need to know is that an attacker starts sending a communication, opens a communication request to our SSH server, sends credentials, gets back failed messages, that repeats some number of times. That would be a set of actions that would define the SSH brute force attack. Most organizations don't define events in that manner, especially in user policies. I've taken this in the next 2 slides, these examples from the National Center for Education Statistics and their sample acceptable use and agreement policy. Often organizations will define events as based on intent. Users shall not intentionally seek information on. Well, that's definitely intent. Malicious use. Well, if it's malicious, that's an intent. That's not something concrete. Any use for the network for commercial or for-profit purposes is prohibited. That's an intent. We can't view intent as an analyst based on most of the data that we have. We also have this subset of types of events that are definitions that are arbitrary, excessive use, or subjective. What is an inappropriate text file as determined by the system administrator? That is very subjective. Hate mail, chain letters, harassment, that's all abstract actions. What we as analysts need are something closer to, although this still doesn't get down to the level where we as analysts need it. Unauthorized installation on the software, playing games is prohibited, establishing network or internet connections to live communications. Those are things that we as analysts can start to work with because we have a good understanding of what those actually mean. So this is supposed to be a workshop. What I'm going to do is I'm going to talk a little bit about anomalies and indicators and definitions around that. I'm going to talk about how I like to think of defining events, or more accurately, the actions that make up events, in something that I am, as of right now, calling the action definition matrix. And then I'm going to have a conceptual discussion where I have some workbooks. They're on the back 2 seats on each side of the room. If you want to get one, you can. If you don't really need one. But I would like to facilitate some discussion of actually applying the definition concepts to several hypothetical attacks or events based on very generic network landscape using network flow. When we have events based on actions, let's see, we have a landscape. So we have a set of, as any organization has a landscape. The landscape is made up of different assets. This is very generic, but it gives you a pretty good idea of the different components that make up the network, or really the organization, for any number of organizations, companies, whatever. Some of the assets we have devices that users interact with, top corner labeled users. We have devices that provide services. Users may or may not interact with those directly. We have devices that the outside world interact with, your DMZ zone. You have firewalls, you have routers, you have users themselves, which are assets. Also, you have reputation. Reputation isn't something that normally people think of as an asset, but it really is. And if you don't believe me, think about the spoofing attacks. If you have spoofing, that can really degrade your organization's reputation. In some cases, it can land you in like a spam list. So maybe you can't get your email delivered. If I wanted to give a known description of an action, of one of the actions that make up an NTP distributed reflective denial of service attack, I could say something like outgoing response volume to incoming request volume exceeds 555 to 1. That's a ratio that you get off the US CERT website. You can do the same thing with disrepute. You can say something is spam if it's an email from a blacklist. You can do the same thing with an unknown. So an unknown description could be an action where an IP address contacts a DNS server but doesn't use a DNS report. That could be an unknown description because you don't really know what the action is, but it's a set of characteristics that isn't expected behavior. For an unknown deviation, you might have something like the device's outgoing byte volume quadrupled from what it has been historically. And you do the same thing with disrepute. Any questions so far? Anybody want to discuss any of this? No? Does this make sense? Okay. Before we can actually define our actions or our events through the actions, we have to think about the different logs that we have available. Logs come in many different types. The very most basic will have something that indicates the actor, something that indicates the action, something that indicates the location, something that indicates the asset. Often we have logs that just the fact that it's in a specific log indicates the asset and the location. For instance, an application log, well, the log itself is what indicates the asset and the location. There might not be an actual field for each record within the log for all of these items. More detailed logs obviously provide more in-depth characteristics. They may actually provide replications of the action. For instance, full packet capture, you could actually push a packet through your network and see what it does. When we make our definitions based on the actions, we have to make our definitions use the data we can see. We can't use the detailed fields from an in-depth log if we only have the most basic fields. If we only know the actor and location, then we can't say it happened on a Windows machine. Unless, of course, that is indicated by the asset. Any questions so far? Do I need to go into more depth than any of that? Go back to events? Okay. I know this is pretty basic. So how does this actually play into hunting? Well, obviously this wasn't in yesterday's presentation, but when we hunt, we want to look for security events that we're not yet alerted to. So we need to think of the events that we want to find. Once we've done that, we can identify the actions that would occur, identify actions that are least likely to be legitimate, and then build some sort of definition for each of those actions. Each of those definitions would be one of these 6 types. So I'm going to give an example, and then I would like, if there's interest. If not, then I'm not really sure that I have anything else to discuss how we would actually do this with certain types of events. and it has this many bytes. It started at this time and it ended at this time. Does that make sense? Your network flow can summarize. Yes. When you have sampled network data, there's two ways you can sample the data. You may only get your sensor may only pick up information for maybe 1 out of 100 flows. That's not very useful if you're an analyst and you need to see, did an event occur? Well, you only got 1/100th of your data. How do you know that your event did not occur in the other 99% of your data? Well, there's another way of sampling it, and that is it picks out packets instead of complete flows, in which case your whole summary is going to be off because it only sees individual packets. So you may have a communication, say maybe I sent you 10 packets, but if I'm only sampling 1 out of 100 packets or 1 out of 10 packets, I'm only going to see that I sent you 1. I'm not going to know that I sent you 9 more. That's the difference between sampled and unsampled. If it's unsampled, I will see a record of every single packet that passes the sensor. Yes. Correct. Correct. I tend to think of flows as unidirectional. In other words, I send you, that's one flow. You send your responses back to me, that's another flow. There's ways it's easier to put the flows together and see which side has more communications than it is to pull them apart. Because if you sent me more than I sent you, I don't know that in a bidirectional flow where the flows both sides of the communications are combined. So I think we can stick with assuming that they're unidirectional for these discussions, but either way actually works. You just have to know the difference so that when you build your definitions, you build your definitions appropriately. There are other variations as well. All network flow does not have the same fields. It depends on the utility you use to collect the network flow, the utility you use to store the network flow, and probably the utility you use to analyze it, although most of it is all packaged into one product. Almost all network flow products that I've seen have included at least the source and destination IP address and ports, the protocol indicator, usually a number, the number of packets, the number of bytes, at least the start time, usually the end time or the duration, which you can then calculate the missing field. If you have ICMP, they'll include an ICMP type or code. And the TCP flags is very nice, but often not included. But for this discussion, we'll assume that they include the TCP flags because it makes it a lot easier. So I think some Cisco devices don't break it out between initial and session, but will give you the give you all flags that are seen, which in some network flow programs they'll call all flags. I like it when they break it out by initial and session because it helps you understand, especially with TCP, who started the communication. If you see the SYN as the initial, and not an ACK, you know that person, that side started the communication, unless it's some weird attack. We also know sensor location. That's very important because that tells you which of the actions you would see. If you only see it at your border, you're going to see a different set of actions than if you see internally, especially if you have a NAT device in between. So we're going to say that for our discussion that all routers in our sample landscape are collecting the network flow. So if you have one of these, you actually have a picture of it. If anybody wants to pick one up, they're back there. I'm not sure if there's there's an electronic copy of this in the data download along with the PowerPoint or not. But now I'm going to change the slide because I have 4 scenarios. My goal here is to really get you guys to think about, if we're thinking about actions for each of these scenarios, what would the actions be, and how would you define those actions if all you had to work with was network flow? So the first scenario is an SSH brute force alert. Obviously, there's something always that piques our interest. Sometimes it's an alert, sometimes, which isn't really hunting, but sometimes it's we came across something on the web, we had a blog post, or your boss comes to you and says, I heard about this thing, what is it? Go see if it happened. So with an SSH brute force alert, what would be the actions? Do you want me to walk through this one, give some examples first, and then work together on the others, or maybe I'll just start and see what you give? Right. Correct. So some of the actions would be somebody, I don't know, if we're interested in internal or external, we'll just for a moment say external, sends packets through your router on the outside, through your firewall, through your router on the inside, to your SSH server. So you could see the flows at two different locations, flow at the first router and flow at the second router. Another action would be, well, we know that there's going to be a SYN, so the first packet's going to be a SYN packet. Then you're going to have another flow that the first packet is going to be the ACK, because SSH is a TCP protocol. You have a three-way handshake, SYN, SYN-ACK, ACK, whatever. So it's either going to be a SYN or SYN-ACK, depending on how things are set up. Then you know that eventually it's going to be repeated, so there's going to be a high number of packets, at least in one direction, and one side, because one side's going to be the server, one side's going to be the client, is going to have higher bytes. Which of those would be least likely to indicate legitimate circumstances? One of the biggest problems when we're analysts is, okay, so we have a set of actions, maybe we've even defined them accurately, but a lot of legitimate things look like those actions too. So which would be the least likely to indicate legitimate circumstances? I think one thing that you missed with the SSH server for a brute force alert is we have the actions. So we have one flow going one way, one flow going back. You're going to have a number of packets, you're going to have a number of bytes, but you're probably going to have that repeated a lot of times because you're going to have failed attempts and your server eventually is going to kick it off. So you have to start again. Most servers will cut you off after 3, and then you have to try again, even if they don't actually lock out your account. So you're going to have it repeat maybe 20 times. The repeating of the a malware blog. So you came across the blog post, it discussed the new variant of malware. You decide to look for it on your network. what are the actions for malware? If we go back here and we think that an action involves an asset, involves an actor. When I say actor, I don't necessarily mean a person. It means some device that itself is initiating the action, usually on behalf of a person. It has a location. So for malware to actually come in, to be successful, to have a malware event, what would have to happen? First of all, we have to be a little bit more specific about malware, this new variant of malware. What do we want it to be? I don't necessarily mean a type, but how do we want it to spread, etc. How does the blog say that we get it? There's no right answer.
For my work, the example is like we got infected with a spam bot.
Okay.
So, how did it get all my web servers, right?
Right. So then, okay, so if you get infected by a spam bot, well, what are some of the actions? What would be the first action that would have to occur for you to eventually have gotten by a spam bot?
In my case, at least from what I saw, it looked like it was probably like the post.
Okay.
Like if it's after that, you start seeing the other behavior. You see a lot of hits, and then after that post, you now see my email server just
So the first action, and this you can't really see anywhere, is that the attacker created the, in your case, HTTP post command and did something with it. Well, that command, so he creates it, he sends it somewhere, which means it has to go through a router. The router has to relay it, so that's an action. Then it goes through the firewall has to pass it, that's an action. Your router, because there's another router in there, gets it, has to reroute it, that's an action. Then it gets somewhere. Wherever it gets, okay, so that application has to process it, that's an action. Then from there, you go on. So you have that whole set of actions. Now, of those actions, if we disregard the fact that we only have network flow, what would be the most likely to indicate that this is not legitimate? Yeah, say we had sensors everywhere. Yeah, we have log files everywhere. If we had log files everywhere, what would be the action that would be most likely to indicate that this is not legitimate? Right. Right. If we wanted to define that, would we use characteristics or deviation? So if characteristics, it's a set of attributes, and deviation, it's some change in trend or from threshold. So yeah, probably the attributes. Right, so we know what a standard would look like. So we'd have, these are the good things, not in the set of, so if it's not in that, it's probably an indication that that's related to some event, not necessarily the one that we are interested in, but it's related to some event. So we could have that as, it would be a good description. So if we don't have the logs on our web server, what would be the next likely action that would lead us to that this is an event? Is there anything that we could use to infer that maybe there was some bad HTML? Maybe.
Well, then there's, I know that there's a whole bunch of
with, say we have sensors everywhere. If we're looking for exfiltration, what would be the actions that we would expect to see? Let's say that the specific, first of all, do we want to look for insider threat, exfil, or external? There's, okay. So what would be the actions that we would expect to see? So we could narrow it down, say, okay, I have a data store, maybe my database server in the corner. So for this particular hunt exercise, I'm going to look for data that is moving from the database server when it shouldn't be. Now we could think about this. Okay, so if it's moving from the database server when it shouldn't be, what does that mean? What would be some possible actions? Well, it could be somebody who is not authorized, a user ID that is not authorized, that would be our actor, to access the database server or to download from the database server. We could try something like the root server is transferring data. Why is the root user transferring data? That wouldn't make sense in most scenarios. That's not a legitimate use for the root user. What would be some other ways that we could actually define the action of being removed from the database server? Yes. Right, we can use deviation. We can say that if it's outside of the normal time frame, if the communications last too long, if it's too much data is being transferred in a given time period, or somebody who normally posts all of a sudden starts pulling down. Those would all be ways that we could actually tackle the problem. And for this particular case, if we're looking for something as generic as exfil, we would probably want to investigate all those possibilities. For exfil, because a lot of the definition is based on somebody's doing something with a lot of data, that makes it a little bit easier to find indication within network flow. So if we take those actions and one of the indication that it's exfil is that there's a lot of data that is anomalous, it's a deviation, we can trend on our network flow between different addresses and start thinking about, okay, if we can track this, when does it change? Has it changed more than X amount? That would be probably one of the ways that we would start looking for exfil. But of course, again, because network flow isn't very discriminative, in other words, there's a very limited set of characteristics that we can look at. There's a whole wide range of actual actions that any of those characteristics define. It's still going to be a little hard to really say with any certainty in network flow, but it's going to get us closer to looking into what it is and be able to narrow our search with more detailed logs if we have them available. Anything to add to this one? Questions? Yes. Correct. Yes. Yes, that's a very big thing. One of the things that I find very helpful as an analyst is when I have high-level data like network flow that I can use to start filtering out and narrowing down my search. So I know that at the network flow level, this action will look like this. A bunch of other things will too, but then I've just cut down 90% of the traffic that I need to look at or the ideas that I need to investigate further. Then you can go down and drill down into a more detailed log, and you've already been able to filter out a lot. The last scenario I had was an actual malware infection, not just malware spam. So the scenarios if your management wants you to say if there's any particular malware on the network. Of course, there's no way to be certain, but you still need to be able to tell them to look. What are some of the things that you're going to do? What are some of the actions that you would expect to see specifically from a malware that might indicate a malware infection?
This specific malware they're asking about, or just malware in general?
Malware in general, because that's usually what management asks. Yes. Right. For network flow, if that's all you have to look with, and often when it is what you have to start with, it's really important to understand what's going on in your network normally, and not only that, to actually understand the actual layout of your network. So it really helps if you know that you have this section over here that has these addresses that they're user devices. Down here, these are all my servers. I know a lot of organizations don't even have that level of detail because they haven't kept it up. They may have started with a really nice network diagram, but after time, they don't update the network diagram, but they update their network. As analysts, we often have to come up with ways to get around that, so it becomes a requirement that not only do we find events, but we also be I'm not sure when he walked in, but the anomaly and signature, I often see that people don't understand how they overlap or don't overlap. Anomaly, if you really think about it, is just anything that's unexpected or out of place. A signature is some sort of characteristics that define an event. So there is some overlap. Often organizations don't realize that. So they'll say, give me something that is an anomaly detection product because I already have a signature detection product. I've noticed that a lot of things that are labeled as anomaly detection really do their anomaly detection based on signatures. Some of the signatures get into the realm where they're starting to actually deal with deviations. So the anomaly and signature, I would like at least my clients to start moving away from that terminology and thinking about it more in terms of, I have something that finds events based on description, something that finds them based on deviation, and something that finds them based on disrepute. Yes. Correct. And I think as analysts, that's how we view things most of the time. But because at least when I get the requirements I don't work internally in IT. We have customers who give us problems to solve. When they're presenting those problems to us, they're not analysts, so they don't talk about it in that way. They often will talk about signatures and anomalies. Sometimes really when they you never quite know what they mean when they say anomaly. Do they mean something that's new? Do they mean something that's a deviation? It's not always clear. And sometimes even within the same document, they'll be using the same word to mean two different things because they don't understand the concept. And yes. Exactly, yes. And I think we could get them to move away from that a little bit. It would make our jobs a little easier because then we can start pressing them a little bit more. Okay, so you have this. First of all, help me define the events. What is it that you really care about? Don't tell me that you care about exfil. Obviously, be more detailed. Do you care about internal exfil? Do you care about external exfil? Do you care about any large amount of data being moved through your network or only off of a specific device? Thinking at things at that level and defining the end impact, the adverse action, how the event is adversely impacting their asset in their mind, really helps us as analysts to go and define all the actions that we might actually be able to find and find whether these events occurred or not. Yes? Okay.
So let's say, for example, that in your environment now 10 files.
Yes.
And let's say that there are 10 different locations.
Mm-hmm.
Let's say for a number, you have 1,000 tasks.
Right.
Will you want to know?
Mm-hmm.
For the time being, you have 10 targets that need a task. And it is actually the next thing. It's got commonality.
Right.
How would you correlate with flow data, or how would you go about thinking about correlating with flow data, those 10 common targets to those 1,000 unique patterns from different locations to the target?
So I have started thinking about that idea. I haven't gotten very far, but I think it's going to come down to how you segregate your data. So what I started doing, and I haven't really gotten very far, although I think the concept makes sense, is, okay, if we start breaking out data, we can break it out by protocol. Eventually you're going to get down to bins where flows, or preferably devices at start, but then flows all have the same set of characteristics or very similar that seem to indicate the same thing. If you can actually bin your data appropriately, I think that would help you correlate to see that, oh, this is 10 things that are having all the same thing happen to it. Maybe there's other things happening, but there's this set of characteristics. If you're talking about network flow, they have the same packet range, byte range, time range that seems anomalous for whatever reason. Then you can start looking and saying, are these related? Are they the same attack? Is it some bigger exploit? I think eventually it might be good to be able to start putting some of this into machine learning, but I'm nowhere near that. Yes. Did you have something to add? Okay.
How do you establish what is normal or abnormal? How would you go about manifold? How do you go down? Or is that outside of the realm of this?
I'm open to talking about whatever. Situational awareness is very difficult, especially if you're not starting with a clean network. If you're starting with known good, which you can do to an extent on most networks, you probably know that a subset is okay, fine. You just bought it and you just plugged it in. At that point, it's known good. And if you start right then, you can start profiling and tracking. Where you start getting problems is when obviously you come into a network that's already exists, and now you need to determine what's normal. Well, what's normal may be the fact that you are already compromised, and you have no way to tease that out. I don't know the answer to that question. My hypothesis, and I've started playing around with this, but haven't gotten far enough to actually see any results or be able to say if my hypothesis is anywhere near correct, is that you need to do two things. You need to compare devices to themselves over time, and you need to compare devices to similar devices at the same time. Then you're going to be able to start seeing differences from both my own historical behavior, something's changed, and why, if I'm supposed to be doing the same thing as if this other set of devices, am I not? So you're going to have like two different views into the same problem.
More difficult because it's not your data.
So I think my problem is not that it's not my network. It's that my customers either don't understand or don't have the ability to instrument their network in the way that answers the questions they want to ask. Yes. Well, yes and no. I think the basic problem is that a lot of our customers, and whether they're government, because we are an FFRDC, or commercial, because we do occasionally have commercial customers, is that they weren't aware of the data they needed to answer the questions that they now want to ask, so they have no way of getting it. So when you have events, and actually let me bring up the slideshow. So they don't necessarily understand the concept of events are made up of actions. Each action has a location. Well, if you need to see actions, you need something that tells you, that relays that back to you as the analyst. So they look at logs and they look at logging from a performance perspective. Okay, where do I put the log to monitor my performance? Where do I not put the log to not impact my performance? Logging is expensive. Logging gives you too much information to process. So there's a lot of reasons for organizations not to log, and they don't understand the reasons why they should log and where they should log from a security perspective.
Yeah, but we created thinking, I mean, that whole originally was not intended as a security protocol.
Correct.
So now, like you made, and then figured out, sample item, use it for security.
Right. Yes. It does lead to creative thinking. We're called upon to do that all the time. It doesn't always help. Sometimes it does. There are certain things where you can really heuristically, imply that this network flow implies this. But there are, even no matter how well we are skilled, there are certain things that we are never going to be able to tell. And it's really frustrating as an analyst when we have organizations or our management come to us and say, but what about the false positive rate? Well, you just gave me something where everything looks the same and you want me to pull the information out of it. as an analyst, sometimes you run across the concept, well, but I don't have the physical ability to store all the data you need. Well, how do you manage that? Are there some ways that we can go about deciding what it is we store based on how we expect to use it? And then there are there's a list of a few free tools that if you would be interested in playing around with network flow or full packet capture, and there are some sample data sets listed as well. So yes, the first two, the Silk tool suite and the analysis pipeline, are actually provided by our organization. They're on the CERT website. Wireshark, I think that's an open source project, but when we actually have access to full packet capture, which isn't often, that's usually what we use. So there are some others. I'm not sure that they are free. I think Bro is free, except if you want support. The Silk tools, we have a mailing list that if you have problems, they're very helpful. Okay. So if nothing else and you don't want to talk about anything else, then that's all I had.